Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our first PU Computer Science online classes. In today's class, we are going to start the new chapter, the chapter 3, name of the chapter, data representation. Now, in this chapter, we are going to study about some number system. The number systems are decimal number system, octal number system, hexadecimal number system, or maybe the binary number system, as well as we are going to learn about some conversion, all types of conversion, that is from decimal to binary, binary to the octal here, octal to binary. So all type of conversion are going to occur in this chapter. Okay, now let's later was all those each and everything. What about the conversions here? Now first of all, in this chapter I want to say some introduction part. So what about the in our data representation? That means we are going to represent some data in the computer. As we know that the representation of data in the computer, we can do it by using bits format. The full form of the bits format is the binary digit. The values are 0 and 1. As we know that the computer understand only two format, that means bit format 0 and 1. Okay. Now in our introduction only I want to say each and everything. So we know that our digital computer, or maybe our computer, we can say in simple meaning, our digital or computer here, the data, maybe you want to store some of the data and instruction, then sure the data and instruction are stored in the computer's memory. Correct no? ಈಗ ಯಾವುದೇ ಒಂದು ನನಗೆ ಕಂಪ್ಯೂಟರ್ ಅಲ್ಲಿ ಏನೋ ಒಂದು ಇನ್ಫಾರ್ಮೇಶನ್ ಅನ್ನು ಸ್ಟೋರ್ ಮಾಡಲಿಕ್ಕೆ ಇದೆ, ಹಾಗಾದ್ರೆ ನಾನು ಆ ಇನ್ಫಾರ್ಮೇಶನ್ ಅನ್ನು ಎಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತೇವೆ? As we know that maybe any data and instructions are going to store in the computer's memory. Correct no? And how we are going to store? As we know, our computer understand the bit format, or we can say that using binary code or machine code. Correct no? Represented by using our binary digit. Maybe you can say by using many names, but the values are 1 and 0. You can use the name for the value 1 and 0, maybe the binary code, or maybe you can say as the machine code here, or in simple meaning you can say as the binary digit, or in short form you can use the name as the bits. Correct no? So we can say that maybe the binary code, machine code, bits, or maybe finally the binary digit are the 1 and 0. Correct no? The 1 and 0 are called as the bits, in this case BITS. So what's the full form of the bits? As we know that the binary digit only called as the bits here. That means the bits short form and full form of the bit is the binary digit. Okay, we know that the computer representing the data just by using the format, that is the 1 and 0 called as the bits here. Now maybe I want to, that means just only our computer just accepting the digit alphabet here. No, we can say that the computer may contain accept any kind of the data. Maybe the data is the alphabet. Correct no? A to Z, any kind of data the computer can going to accept here, or maybe the digit 0 to 9, or maybe we can say that the special character, the special symbols, the special character or the special symbols are less than, greater than, equal, plus, minus, question mark, single quote, semicolon. Correct no? Caret symbol here, one's complement here, single quote, double quote, maybe the parenthesis, flower bracket. So many type of these symbols are called as the special characters. So our computer accepting or contain or accepting any kind of the digit, any kind of the alphabet here, or maybe any type of the special characters, and after accepting such data going to convert into the binary digit format. Correct no? The 0 and 1, because we know that the computer understandable very easily all those or all this format here. The format is the 1 and 0. So all arithmetic operations are going to perform by using the binary code or the binary digit, or we can say that binary bits only. So all those points just we can say we can add in our introduction to our or introduction of the data representation. So ಅರ್ಥ ಆಯ್ತಾ ನಾನು ಇಂಟ್ರಡಕ್ಷನ್ ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ದೇನೆ? ವೆರಿ ಸಿಂಪ್ಲಿ as we know that what I said in our first chapter, what's the data, how the data going to add into the computer that means accepting, how the computer going to accept all those data here and which language the computer understanding here, each and everything just only I added in our introduction to our data representation. Okay, now after completing the introduction here, now let's about our, shall we select the next concept, that is the types of number system. Okay, the types of the number system. So we can say that here when you are going to think about our types of number system, such number system are classified into two types. Okay, how many types are there in number system? Totally there are two types are there. The types are, the first type we can say as the non-positional number system. Okay, the non-positional number system, and the second type we can say as the positional number system. So what's the difference to our non-positional number system and to our positional number system? So here we can say that in our positional number system, for each number we need to give some of the position value. Maybe one example, when you are going to use 1 3, clear this point here, 1 3. So that means we can say that here we are going to give the position value. Maybe if you are using binary number system, so the 2, okay, because we know that the base of the binary number system is 2 here. So positional value going to represent 2 to the power of 0, 2 to the power of 1. So like that, for each unit, for each number we need to give the positional value, that is called as the positional number system. Later on let's see about all those explanation or many or more explanation I will give later words. Now just here till here I want to say here just only two types of number system are there. The first one is called as the non-positional number system and second one is the positional number system. Now let's about our non-positional number system. So what about the non-positional number system? So here we can say that here in our non-positional number system, in this case in our olden days the man used to count number. Maybe if they want to count some of the numbers, they don't know about the number in this case, because we know that in our positional they introduced some of these symbols called as the digits. But in case of the non-positional number system, maybe when you are going to think about in olden days here, on that time maybe for any person if they want to make some of the counting, that how it possible to do such counting, that means by using maybe these sticks. Okay, depend on these sticks they are going to say the number. Clear this point here, the number of these sticks after counting 1 2 3 4. So depend on these sticks they can say that what's the number of these sticks here, or maybe they are going to use the fingers, okay, just to count the numbers here, or maybe they are going to use the stones. Clear this one. So ಇಲ್ಲಿ ನಾವು ಹೇಳ್ಬಹುದು just olden days ಅಲ್ಲಿ ಯಾವುದೇ ಒಂದು ನಂಬರ್ ಅನ್ನು ಕೌಂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅವರು ಯಾವುದೆಲ್ಲ ಯೂಸ್ ಮಾಡ್ತಿದ್ರು. So here we can say that they are specially going to use maybe the stones, okay, while going to count the numbers here, maybe the sticks here, and also they were using the stones in this case. Clear these one, fingers, each and everything, and just depend on this they can say that to represent the numbers they are going to tell the numbers in this case here. So clear this point in this about our non-positional number system. So we can say that in our non-positional number system the people made use of this type of number system, correct no kya? And such non-positional number system are suitable for our simple calculation only, maybe the addition and subtraction. Maybe you want to count a million of numbers here, is it possible by using our non-positional number system? That means sure we need to use a million of these stones, correct no, a million of these sticks in this case. So we can say that such a non-positional or a special specially such a non-positional number system specially going to use just for our simple calculations like our addition and the subtraction. And this non-positional number system consists of different symbols. Many of the symbols are there and we can say that are used to represent the numbers. So now ಯಾಕೆ ಆ symbol ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ? Because we know that such a symbol are specially going to use to indicate the value, to represent the numbers in this case here. Correct, no? So this is about our non-positional number system. So very good example or the suitable example we can use for our non-positional number system, that is the Roman number system, is an example of our non-positional number system. Clear this one here? So non-positional ಗೆ ನೀವು ಹೇಳುವುದಾದ್ರೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಡುವುದಾದ್ರೆ ಯಾವುದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀರಿ ನೀವು? So Roman number system here. Clear this one? As we know that I already explained, I already said the non-positional number system consists of the different symbols. Correct, no? The different symbols are going to use, and all those symbols are using to represent the numbers. So the symbols are maybe the first one, that is our I is equal to 1 here, V value is equal to 5, X value is equal to 10 in this case, and later L value is equal to 50. That only called as the symbols. That means our non-positional number system. The non-positional, the example I already said, it using the different kind of the symbols. Correct, no? It using many of the symbols here. So some of the symbol examples, that is I is equal to 1, V value is equal to 5 here, X value is equal to 10, and the L value is equal to 50 here. Just only some of the examples are there. But also we can say that, as we know that means our non-positional number system, each of this symbol represent a value. Correct, no? The each symbol representing some value, indicating the value, representing the value here. Maybe if you are using this symbol V, that means it representing the value 5. Maybe this symbol L, it representing the value 50, indicating the value 50 here. So each of these symbol represent a value irrespective of the positions. That means in our non-positional number system, there is no importance to our position value of the numbers. Okay, here no any importance to our position of the numbers here. But finally we can say, but what's the disadvantage of the non-positional number system? So the main disadvantage of the non-positional number system, we can say that means it is not suitable to represent a large quantity of the numbers. Clear this one? That means just only very simple number we can use, we can represent here, maybe the I, V, like that. But maybe in case you want to just use maybe the longer number, a large quantity of the number here, that means that non-positional number system is not suitable. Clear this point? Or we can say that it is inconvenient to represent large quantity of the numbers, and finally so that cannot be effectively used to perform any type of the arithmetic operation. Because of some disadvantage of the non-positional number system, they were introduced the another number system. The another number system is called as the positional number system. Artha aita? Iga now we are in the second type of the number system. Now just I selected the second type, that is our positional number system. Yakendre namge gottide non-positional number system alli each symbol represent the value, but is it possible to count a large number by using non-positional number system? No, it very difficult, as we know that it is the disadvantage of the non-positional number system. Correct? Now when you are going to count, that means it's not possible to represent large quantity of the numbers and cannot be effectively used to perform the arithmetic operations like addition, subtraction here. Correct, no here? So it is inconvenient. Because of this reason introduced the another number system. Another number system is called as the positional number system. Okay, now we'll go for the second type, that is about our positional number system. ಯಾಕೆಂದ್ರೆ ನಾವು ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದೇವೆ non-positional ಗೆ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಏನು ಕೊಟ್ಟಿದ್ದು Roman number system, and I already given some symbols. Correct, no? In our Roman number system here, now the positional number system ಗೆ ಯಾವುದೆಲ್ಲ ಎಕ್ಸಾಂಪಲ್ ಕೊಡಬಹುದು? So we can say that the decimal number system, binary number system. Clear this point here? And maybe the octal number system, hexadecimal number system are some of the example of this type of, that means the positional number system. So some of the example, the first one is the decimal, okay, the second example we can use as the binary, and third example we can say as the octal, and later next one, the last example we can use, that is our hexadecimal number system. Clear this point here? The hexadecimal number system are some of the example of our positional number system here. As we know, some of the disadvantage of the non-positional number system here. So we can say that this number system was created, correct no here, to avoid the problem of having to create and remember large number of these symbols. As we know that our non-positional number system using some of these symbols, so it very difficult to create, it very difficult to remember here what's the use, what's the that means we know that each symbol having some of the indicating some of the value here, it's very difficult to remember, correct no? Here we can say that here in case of the positional number system, that means our positional number system was created just to avoid the problem of having to create and remember large number of the symbols. As we know that in our, what's the disadvantage of the non-positional number system, correct no here? But also we can say that our positional number system uses well-defined symbols, and such symbols are called as the digits. ಯಾಕಂದ್ರೆ ನಾವು ಹೇಳ್ಬಹುದು ಜಸ್ಟ್ ನಮ್ಮ ನಾನ್ ಪೊಸಿಷನಲ್ ಅಲ್ಲಿ ಮಾತ್ರ ಸಿಂಬಲ್ಸ್ ಇಲ್ಲ, ನಮ್ಮ ಪೊಸಿಷನಲ್ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಕೂಡ ಕೆಲವೊಂದು ಸಿಂಬಲ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೇವೆ, and such symbol are called as the digits. Clear this point here? Are called as the digits in this case here. So here we can say that the one example for the digits in this case, maybe we can say about 123. If you are using the 123 number, 123, as we know that if you are using binary number system, that means the position value of 3, 2 to the power of 0, the position value of 2, it's a 100 place. Clear this point here? That means it is the unit, it is the 10, it is the 100 place. So we can say that the unit 2 to the power of 1 and 2 to the power of 2. Like that we are providing some of the position value to each number. Clear this point here? Artha units, tens, hundreds in this case here. So like that we are providing some of the position value to the numbers. So we can say that our positional number system also uses some of these symbols, and such a symbol are called as the digits here, and the value of the digit depend on the position in which they appear in the number system, correct no? Because we know that this number appeared in our position, the position value is the units, and this number appeared, the position value is the tens, okay, and this number appeared in position value hundreds here. So we can say that that means the value of the digit depend on the position in which they appear in the number system. So artha aita ellariಗೆ about the symbols of the positional number system here, okay, here, okay. Now later next one is about after completing the positional number system, now let's the meaning of the base value. Clear this point here? The meaning of the base value. Now next thing about the base value. So the base of the number system defines in this case the total number of different digit available in the number system. So this is the definition of the base of the number system. So maybe I think little bit confusion. I just said in word, correct no? That means still here you don't know what I said in the word. What's the sentence I framed in case of our base of the number system? I said in case of the base of the number system defines the total number of different digit available in the number system. As we know that the decimal number system, if you are using decimal, the decimal base or radix is the 10. Clear this point here? And total numbers it going to start from 0 to 9, that is equal to 10 only. Clear this point? So ಇಲ್ಲಿ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೇನೆ ಈಗ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಬೇಸ್ ವ್ಯಾಲ್ಯೂ ಡೆಫಿನಿಷನ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೇನೆ. So first of all I want to take the first number system, the number system is the decimal number system. As we know that the base or the radix, RADIX, clear this one, the base or radix of the decimal number system, that is equal to 10 here. The number going to start from 0 to 9, that is equal to 10, okay. And later when you are going to use the binary number system, the base of the binary number system is 2 and the values, it contains the value 0 and 1, clear this one. Totally it contains the value 2, that is equal to the base of the binary number system. And when you are going to use the third number system of the example of positional number system, that is octal number system. The octal number system has 8 digits, totally 8 digits ಇದೆ. ಆ digit ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ, 0 to 7, that is equal to 8. So this is only the base or the radix of the octal number system, clear this one. The base or the radix of the octal number system, that is equal to 8 here. And later the last number system, the number system is the hexadecimal number system, okay. So the total, the hexadecimal number system has, or it contains, the total digit is the 16. So the digits going to start from 0 to 9, okay. And also A, B, C, D, E and lastly we can say as the F, clear this one here. 0 to 9, 10, 11, 12, 13, 15, clear this point here. So we can 10, 11, 12, 13, 14 and the 15 respectively, clear this one. So totally when you are going to add 0 to 9, that is equal to 10, and also this 5, that is equal to our 5, that is equal to the 16. So we can say that here base of the definition ಇದೆಲ್ಲ ನಾನು ಯಾಕೆ ಬರ್ದದ್ದು, just to explain the base value of the number system. So the base value of the number system define the total number of different digit available in the number system. Decimal ಅಲ್ಲಿ 10, clear this one here. And total values, binary ಅಲ್ಲಿ 2, the total value 0 and 1. Octal ಅಲ್ಲಿ 8, the total value 0 to 7. And hexadecimal total value digit, okay, kya 16, that is from 0 to 9. And also the A, B, C, D, E and F may be capital or the small, that is our hexadecimal number system. So clear the meaning of the base of the number system, okay. Now after completing the base of the number system, as we know that still here we completed about the introduction of data representation in computer, how we are going to represent the data in computer. As we know that by using the format is the bit format, and the bit format accepting the value 0 and 1, correct no. And whatever the data we are going to input through the keyboard, maybe the data like alphabet, maybe data digit, or maybe any special character, later such data are going to convert into the bit format that is understandable by our computer. And then we completed the types of the number system, that is the positional and non-positional number system, correct no. And as well as we completed the definition of the base of the number system. And after completing, finally we can say that the positional number system includes some of the number system are the decimal number system, binary number system, octal number system, hexadecimal number system, correct no. Now let's the first point I want to select the number system, that is the decimal number system here. So you have to listen it properly, because if you want to solve any number conversion, then sure you should know the meaning or the explanation of each number system. Now just I selected the first number system. The first number system name is the decimal number system, okay, the decimal number system. Now this is the most commonly used number system in our daily life, and we can say that hence the radix of decimal number system is 10, okay. So what's the radix about, or the base of the decimal number system? So we can say that the base or radix, that is equal to 10. As we know that the 10 means the numbers are from 0 to 9, correct no, the numbers from 0 to 9. So finally we can say that the positional value are expressed in powers of 10 only. So clear this point here. So this is the some explanation about our decimal number system. ಸಿಸ್ಟಮ್. ಸೊ ಡೆಸಿಮಲ್ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಅರ್ಥ ಆಯ್ತಾ? ಡೆಸಿಮಲ್ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಇನ ಬೇಸ್ ಅಥವಾ ರಾಡೆಕ್ಸ್ ಎಷ್ಟು? ಜಸ್ಟ್ ಓನ್ಲಿ ದಿ 10. ಕ್ಲಿಯರ್ ದಿಸ್ ಒನ್? ದಿ ಬೇಸ್ or radix is 10 here. So that means we can say that it contains the number are going to start from 0 to 9, that is equal to 10 only. So the positional value, what's the positional value of the decimal number system? The positional value of the decimal number system are expressed in power of 10 only. Clear this point here? 10. Clear this one? Okay. Now after completing, now we'll complete one simple example for our decimal number system here. So consider the decimal number 542.76. Fractional point is that, okay, integer part and the fractional point. So number 542.76 base of 10. Clear this one? Base of 10. ಇದು ಓದುವಾಗ ಹೇಗೆ ಓದ್ತೇವೆ? 542.76 base of 10 here, and which can be represented as, maybe if you are going to take the value 542.76 base of 10 here, so which can be represented as the, here first of all we need to give the position value. We are going to start from the fractional point. Clear this one? ಈ ಪಾಯಿಂಟಿನ ನಂತರ ನಾವು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೇವೆ. So the first position, as we know that the positional value of the decimal number system, that is 10. Correct? No, radix or base is 10. So we can say that the 10 to the power of 0, okay, that is called as the units here, and 4 10 to the power of 1, that is called as about our tens in this case here, and 10 to the power of 2, okay here, and this one is called as the 100. Clear this point here? Hundreds place in this case, and later after the point, after the fractional point, how we are going to write? That means 10 minus 1, the positional value of 7, 10 minus 1 here, and the positional value of 6 is called as the 10 minus 2. So this one is called as the 1/10. Clear this point here? 1/10 here, and this is called as the 100th. Clear this one? 100 here. So now we already know the positional value of each number. Now which can be represented as the 5 into 10 to the power of 2, 5 into 10 to the power of 2 plus 4 into 10 to the power of 1 plus 2 into 10 to the power of 0. Now ಯಾವುದು ಬರಿತಾ ಇದ್ದೇನೆ? ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ನಾನು ಏನು ಮಾಡಿದ್ದೇನೆ? ಪೊಸಿಷನ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದೇನೆ. ಪೊಸಿಷನ್ ವ್ಯಾಲ್ಯೂ ಹೇಗೆ ಕೊಟ್ಟಿದ್ದೇನೆ? ಡಿಪೆಂಡ್ ಆನ್ ದಿ ಸೈಡ್, ಡಿಪೆಂಡ್ ಆನ್ ದಿ ಹೆಡ್ಡಿಂಗ್. ಕರೆಕ್ಟ್? ನೋಡಿ, ದಿ ಡೆಸಿಮಲ್ ನಂಬರ್ ಸಿಸ್ಟಮ್ ನಮಗೆ ಗೊತ್ತಿದೆ. ಡೆಸಿಮಲ್ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಇನ ಪೊಸಿಷನ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? ರಾಡೆಕ್ಸ್ ಬೇಸ್ ಎಷ್ಟು? 10 here. So how we are going to give the positional value? That means just going to start from the 10 to the power of 0, okay, here, and 10 to the power of 1, 10 to the power of 2. Now just I completed 5 into 10 to the power of 2 plus 4 into 10 to the power of 1 plus 2 into 10 to the power of 0 plus 7 into 10 to the power of minus 1 plus 6 into 10 to the power of minus 2. Clear this point here? So now we know that such value, how we need to represent here. We already completed the representation of the decimal number system of 542.76 base of 10. Correct? Now let's here one table. So here we can say that this table shows the weightage of the positional value of the decimal number. Okay here? So now first of all the same value I want to take in this table, and here some of the representation I want to do. So the first of all here, and first of all I am going to take the digits. Clear this point here? The digits, that means what's the question? Digits, as we know that the positional value, positional number system ಗೆ ನಾವು example decimal number system ಅಂತ ಹೇಳ್ಬಹುದು. As we know that the number system, the positional number system also gives us well defined symbol, but such symbol are called as the digits. Correct? No, kya call as the digits? Now the digits are 542.76. Correct? No, 542.76 here, and later next one, weights. What's the position value of this number? As we know that here just only the 2, that means after the 2 we are going to start the fractional point. So before the fractional we need to give the position value. Correct here? So we can say that so this one is called as the units. Okay, the units heading is that 10 to the power of 0, and later next one, this one is comes under 10 to the power of 1, that is called as the tens in this case, and later we can say that this position value is 10 to the power of 2, that is called as the hundreds place. Clear this one? 100 place in this case. And after the fractional, as we know that 10 minus 1 in simple way we can say as the 1/10. Okay, 1/10, 10 minus 2, that is called as the 100. So illinda ನಾವು ಪಾಸಿಟಿವ್ ನಂಬರ್ ಆಗಿ ತಗೊಳ್ತೇವೆ. ಲೇಟರ್ಸ್ ಆಫ್ಟರ್ ದಿ ಫ್ರಾಕ್ಷನ್ ವಾಟ್ ಎವರ್ ದಿ ವ್ಯಾಲ್ಯೂ ಇಸ್ ದಟ್ ವಿ ಶುಡ್ ಗಿವ್ ಇಟ್ ಟು ದಿ, that means the negative position value. Clear this part here? So now, okay, now after that, now whatever the number here, some of the number going to show. So what's the number is this? How we got such number? Answer. So we can say that the values, that means such number, how to get the number 100, that means here we can say that 10 into 10. Clear this one? When you are going to multiply 10 into 10, so 10 to the power of 2 times we need to make the multiplication of 10 number. Clear this one? So 10 into 10, when you are going to multiply, the value will get the value as the 100. Artha aita ellarige? And later next one, 10 to the power of 1, that means here just only one time, 10 into 1. Clear this one? So 1 in this case, so value will get as the 10 only. And later next one is about our 10 to the power of 0. Always you should remember it. Maybe the value 10 to the power of 0, maybe the value 2 to the power of 0, or 8 to the power of 0, or 16 to the power of 0. Always will get the value as 1 only. Artha aita ellarige? Adu yaude ಒಂದು ಇರಬಹುದು position value. The position value is the unit value, that means 16 to the power of 0, 8 to the power of 0, or maybe 2 to the power of 0, or 10 to the power of 0. Always the value is 1 only. Clear this point here? So this is the units value. 10 to the power of 0, the value is 1 here. And later next one, 10 minus 1, hege ee answer namge bandide, that means we get the answer just by dividing 1 by 10. Clear this one? 1 by 10 yavaga ನೀವು 1 by 10 ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀರಿ, because we know that after the fractional 1/10 it is representing as the 1/10. 10 minus 1, 1/10. Clear this one? So 1 by 10, the value will get as the 0.1 here. And later 10 minus 2, that means here we can say that how we are going to multiply 1 by here, the 1 by 100 in this case here. So clear this point here, the 1 by 100, so that means we'll get the value 0.01. And later what such value going to multiply 5 into 100 plus 4 into 10 plus 2 into 1 plus 7 into 0.1 plus and 6 into 0.01. Finally we'll get the value. The value is the 542.76. Clear this point here? So lastly we will get the value here. So clear this point here? So this is the representation about our decimal number system. So clear about the decimal number system? Table each and everything is clear, no? And how we are going to give the position value, as we know that means in case of the number system, the positional number system here, the value of the digit, correct, no? Yeah, for each value we need to give some of the position value here. So this is about our decimal number system. So because of it is called as the positional, or it comes under the example of the positional number system. Okay, now after completing the positional number system, now let's the second example of the positional number system. The second example of the positional number system we can say about our binary number system, correct, no? We can say about our binary number system here. So in case of the binary number system, so we can say that means our digital computer cannot process the decimal numbers. Is it, we know that what's the total number? The total number of decimal fractional, that is from going to start from 0 to 9, that is equal to 10. But as we know that whatever the data, that means our computer understand only the format is the bit format. Bit are the binary digit, values are 0 and 1 here. So we can say that our digital computer cannot process the decimal numbers while representing, correct no kya, when you are going to think, when you are going to use the binary number system. So because of that means we know that such value, the decimal number value, it should be converted into the binary digit. Whatever the value is there in decimal number, it should be converted into the binary digit. As we know that computer understand only the binary digit format. The format are the 0 and 1, correct no kya? So here the 0 is called as the low voltage value. Clear this point here? The low voltage value and 1 is called as the high voltage value. Clear this point? ಇದು ನಾನು ಯಾಕೆ ಬೈನರಿ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೇನೆ, ನಮಗೆ ಗೊತ್ತಿದೆ ಡೆಸಿಮಲ್ ನಂಬರ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಪೊಸಿಷನಲ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು, ಅದರ ಪೊಸಿಷನಲ್ ವ್ಯಾಲ್ಯೂ 10, correct no, 10, and total number going to start from 0 to 9 here. But also we know that our computer just using the value 0 and 1, so we know that whatever the numbers are there in decimal number, such number need to convert into the binary digit format. So when you are going to know the binary digit format values, the values are 0 and 1. So 0 called as the low voltage value and 1 is called as the high voltage value here. So which is suitable to represent two state of electronic components, correct no here? So now after completing some explanation about our binary number system, here also I want to use one value, okay, for our binary number system. So consider a binary number system. The values are 11011 fractional, 101 base of 2. As we know our decimal number system base 10, binary number system base, now it is not the 10, now the binary number system base or radix is 2. As we know that it contain, that means it has the value, the values are 0 and 1, correct no? So every value going to use in the 10 10 10 in that format only, correct here? So we know that means here one example is that for the binary number system, and we know that the binary number system representation values are 11011 fractional, 101 base of 2, correct no kya? So which can be represented as, how to write this value here? So when you are going to take the binary number system value, so the values are 110, okay, 11 and 101 base of 2, base of 2 here. As we know that if fractional point in the nano positive number ಕೊಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೇನೆ, clear this point here, the positive position value, and after the fractional going to give the negative position value here. So first of all, as we know that binary number system base value is 2, so 2 to the power of 0, 2 to the power of 1, 2 to the power of 2 here, 2 to the power of 3 and 2 to the power of 4. Clear this point here? So like that we need to give, maybe if any one extra value, maybe the value is 1 here, then 2 to the power of 5. So like that it will go 1 by 1. Clear this one? But here no any value is there. I think no need here, whatever the value, so the same value I need to take in our example for the representation of the binary number system. ಅರ್ಥ ಆಯ್ತಾ? ಈ ಫ್ರಾಕ್ಷನ್ ನಂತರ ನಾನು ಪಾಸಿಟಿವ್ ಕೊಡ್ತಾ ಇದ್ದೇನೆ, ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಕೊಡ್ತಾ ಇದ್ದೇನೆ, 2 to the power of 0, the units like that 1 by 1 it will go. Clear this point here? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4 here, and later after the fractional, that means the negative 2 to the power of 1 here, 2 to the power of 2 for 0 and 2 to the power of 3 for our 1. Clear this one? Maybe if any extra value 2 to the power of minus 4, maybe any extra value 2 to the power of minus 5, like that it will go. So we can say that in our binary number system the representation, that means here the representation of data in the computer is usually in binary format. The binary format are the 0 and 1 here. So the base or radix of the binary number system is 2 here, and also we can say that the positional value are expressed in power of 2 only in our binary number system. So now when you are going to represent this number, how you are going to write? A 1 into 2 to the power of 4, correct? No, 1 into 2 to the power of 4 plus 1 into 2 to the power of 3, okay, 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 here plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. That means we completed by using this value and the positional value here. I completed till here, okay, 1 1 0 1 1. Now I am going to complete the next after the fractional. So plus, okay, this one is the continuation after 1 into 2 to the power of 0. Later was you have to do the continuation, but now I am going to write 1 into 2 to the power of minus 1 plus 0 into 2 to the power of minus 2. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಲ್ಲ, ನಾನು ಎಲ್ಲಿಂದ ವ್ಯಾಲ್ಯೂ ತಗೊಳ್ತಾ ಇದ್ದೇನೆ? 1 into 2 to the power of minus 1, 0 into 2 to the power of minus 2 here, and 1 into 2 to the power of minus 3. So this is the representation of the binary number system. Clear this point here? And later was how we are going to use. So here we can say that 1 into, that means 4 times you need to make the calculation of 2, multiply the 2 here, 2 into 2 into 2 into 2, 4 times, that means you will get the value 16, correct? No, plus 1 into 3 times you have to make the multiplication of 2, 2 into 2 into 2, the value will get as the 8. So 0 into here 2 times you have to make the multiplication of 2, 2 into 2, the value is 4. Clear this one? Plus 2 into, but here 1 time only 2 into 1, the value is 2 only, plus 1 into, I already said one important note. What I said, the important note, maybe the value is 2 to the power of 0, 8 to the power of 0 and 10 to the power of 0, 16 to the power of 0, always it have or it contain the value is 1 only. Clear this point here? And later next one plus 1 into 2 minus 1, ಇದು ಹೇಗೆ ನೀವು ತಗೊಳ್ತೀರಿ ವ್ಯಾಲ್ಯೂ ಅನ್ನು? The 2 minus 1, that means the value is 1 by 2. Clear this one? So 2 minus 1, 1 by 2, the value will get as the 0.5. ಯಾಕೆಂದ್ರೆ 1 rupees ಅಲ್ಲಿ half ಅಂತ ಹೇಳಿದ್ರೆ 1 rupees ಅಲ್ಲಿ half ಅಂತ ಹೇಳಿದ್ರೆ sure we can say that is the 50 paise, correct na kya? So 0.5, 1 by 2, okay kya? And later plus 2 minus 2, that means here we can say that 1 by 4. Clear this point here? 2 minus 2, that is equal to 1 by 4. So 1 rupees ಅಲ್ಲಿ 1 by 4 ಅಂತ ಹೇಳಿದ್ರೆ sure we can say that 25 paise, 0.25, correct? Now 0.25. And later next one is later 2 minus 3, 2 minus 3, that is equal to, so 2 into 2 into 2, 2 2s are 4, 4 2s are 8. So we can say that 1 by 8. Clear this point here? 1 by 8 here. So value will get as the 0.125. So all these are, so like that we need to make the multiplication by using such values here. So clear this point? Now let's the here one table is there about the binary number system here. So shows the weightage of the positional value of the binary number system. So first of all, the binary value I want to take whatever the values I have taken in a question. So such value I want to take here. So the binary value 1 1 0 1 1 fractional, correct? No, directly we can write here in this table 101. So this is the binary number value, okay? And later next one, as we know that before the fractional we need to give the positive positional value. So we can say 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and after the fractional the negative position value 2 minus 1, 2 minus 2, 2 minus 3 here. And I already said 2 to the power of 4, that means 2 4 times multiply. Clear this one? 4 times we need to make the multiplication. 2 2s are 4, 4 2s are 8, 8 2s are 16. Clear this one? So the value will get as the 16 here. And 2 to the power of 3, that means 3 times we need to make the multiplication. 2 2s are 4, 4 2s are 8. So value will get as the 8 here. 2 to the power of 4, that means 2 times. Clear this one? The 2 times we need to make the multiplication. 2 into 2, the value get as the 4 here. 2 2 to the power of 1, that means 1 time. Clear this one? When you are going to multiply 2 into 1 time, the value will get as the 2 only, as we know that 2 to the power of 0, the value always 1, and later next one 2 minus 1, how we are going to multiply 1 by 2, 0.5 will get the answer. 2 minus 2, 1 by 4, 0.25. 2 minus 3, 1 by 8. So value will get as the 0.125. So clear this point here. Okay. Now after completing some of the binary number system, the most important note in our binary number system. Now let's by using one example, I want to say the important note about our binary number system here. So in binary number system, the value 1000. Okay. I want to take one value. The value that one I want to take as the 1000 here, okay, and in our, we can say that now this is our, in this case this is our right hand, correct? No any problem, we can say that without any confusion, this is the right and this is the left hand. Is it right here? Right and left. So in this case we can say that the leftmost, that means I am going to take first of all this one value, okay, this one value, and this one value is there in our left side value. Clear this one? So we can say in case of the binary number 1000 base of 2, okay, the base value we should need to write, otherwise we can't say which type of the number, which number system is this. So the 1000 base of 2, and in this case first of all the leftmost bit, as we know that left hand, right hand, so I am taking the value, that means here just I want to take the value 1 here, so such value is there in our left hand side, so is called as the leftmost bit, okay, the leftmost bit in this case here, that is 1. Clear this one? Is the highest order bit, biggest order bit here, and such biggest order bit is also called as the MSB, also called as the MSB. The full form of the MSB is the most significant bit. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಇದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ನೋಟ್ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೇನೆ. You should know, because while going to make the conversion from one number system to another number system, we should know what's the meaning of the MSB and where we'll get the MS value and the LSB value here. So I said the MSB value will get in the left hand side. Left hand side here is called as the leftmost bit. The value 1, correct? No, is the highest order bit and called as the MSB. The full form of the MSB, most significant bit here. And later next one, after completing the value 1, now let's go for the right hand side value. The rightmost bit, the value is 0, okay. In rightmost bit, the value is 0, is the we can say that the lower order bit, correct here, the lower order bit, and also called as the LSB. The full form of the LSB is the least significant bit. Artha, it's a very important note about our binary number system. That means in today's class we completed some point about the data representation, that is the introduction, and about the types of the number system. We know the explanation about positional and non-positional number system here, as well as some explanation about the decimal number system with the usage of the weightage of the positional value of decimal number, as well as the binary number system table, and later also we know that the LSB value as well as the MSB value. Thank you for watching this video.
Don't forget to like our video and subscribe our YouTube channel for all the updates.